All right, so the next thing we're going to talk about is something called the discriminant. Now, don't get scared of the big word because it's already something you know, it's nothing new. Now, if you take a look at this formula, hopefully you'll recognize this and maybe even sing the song in your head that this is the quadratic formula, okay? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, the quadratic formula will always give you the solutions or the x-intercepts or the roots of your equation. Now, we are going to be able to tell from this formula, without even doing the entire thing, how many solutions and what type they are, okay? Now, so we're going to take a look at something called the discriminant, which is this specific piece under the radical. The discriminant is just the b squared minus 4ac. That's all it is. It's not the radical. It's just the portion under the radical. What the discriminant does is it describes the number and type of solutions to a quadratic equation. Now, remember, solutions also help tell us about the x-intercepts, okay? Now, you're going to have a total of 4 choices here. The discriminant is going to tell us if we have one real, which will be a rational solution, if we have 2 real rational solutions, 2 real irrational solutions, or 2 imaginary solutions. And I'll show you what this is going to look like in a minute. But let's just kind of think about this for a second. In our quadratic formula, if this always is going to give us the answer to my solutions or my x-intercepts or whatever, this portion right here is always a real number, okay? Negative b over 2a is always a real number that we're going to get. However, we can get a couple of different choices under the radical. We can get a positive number that's a perfect square root, such as the square root of 4. That's going to give me a nice, pretty number when I simplify this equation. I can get a positive number that's not a perfect square root, such as maybe 27. That's going to give me kind of a crazy decimal answer if I were to simplify this out. Okay, I can get a negative number underneath here, and that's actually going to tell me, remember, that there's no x-intercepts, okay? Or I could actually get 0. So what we're going to do next is we're going to take a look at how we can tell the graph and this portion of the radical are related. But before that, I just want you to think about this. If we take the square root of 0, we end up with 0. There's one answer here. So the square root of 0 is just 0. Okay, that's one answer that I get from underneath the radical. If I take the square root of 275, that is going to give me some decimal, which is going to be an irrational number. The only way that I can get a rational number underneath my radical is if I have a perfect square. So anytime you have something under the radical that you cannot take a perfect square of, that's going to be irrational because that's some crazy decimal, okay? If I have the square root of 100, that's the same thing as 10. That is a rational number, okay? It's not irrational, it's a rational, it's not too crazy of a number. And if I have a negative underneath the radical, that is an imaginary number, okay? So we're going to take a look and see how these numbers underneath the radical are going to tell us what type of solutions we have whenever we graph our equation. Now, you should have a green foldable. I will go over the first portion with you, and then I would like you to try the rest with your group, okay, or with the people sitting next to you. So what this is this is going to take a look at why the discriminant works, okay? So first, let's remember our quadratic formula. I want you to fill that in here. Okay, then what I want you to take a look at is in this next box right here, I want you to take a look at just the discriminant only. And the discriminant only is going to be this portion right here. So we are just specifically looking at b squared minus 4ac. We're seeing what type of number am I going to get underneath my radical. So the question is, how does and why does the discriminant work? Why can it tell us what type of solutions that I have? So think about this. This portion right here is always going to be rational, right? So if that's always going to be rational and I get 0 under here, I can only add or subtract one number. So I can only get one real solution. If I get an imaginary number underneath here, that means it's never going to cross the x-axis, and I'm going to get two imaginary solutions. If I get a perfect square underneath here, that's going to give me a rational solution because I can figure out that answer. And if I don't get a perfect square, it's going to give me an irrational. So let me show you an example of one, and then I'll have you try the other two. Okay, so your discriminant, remember, we need to find our a, b, and c values. So remember, a is always the number in front of x. So in this case, it's 1. X squared. B is the number in front of x. In this case, it's 10. And c is going to be 25. Okay, it's your number without an x. So what you're going to do here is you're going to do b squared minus 4ac. Just the discriminant. So we're going to figure out what is underneath that radical. So b squared in this case is 10 squared minus 4 times 1 times 25. Okay. So that is going to end up giving me 0. All right, now before we answer this, let's just take a look at our graph, okay? So I graphed this on Desmos. All right, this is what your graph is going to look like. What I want you to notice is there's only one x-intercept. So remember, solutions and roots and x-intercepts are kind of all the same thing. So we want to be specific here, okay? In this case, we're describing how many x-intercepts we have. Well, we only have one at 5, 0. So what I'm going to do here for the graph portion is you don't need to be specific. Just use your graphing calculator or Desmos or whatever. Okay, so I'm just going to graph it right here. But what I want you to notice is the fact that there is only one x-intercept. Okay, so in this case, there's only one x-intercept. So this is going to tell us how many solutions we have. We actually have only one solution. The solution is the x-intercept. In this case, it was -5. Okay, so there's one solution. What kind of solution is that? Well, that is going to be a real solution. Okay, now what that means here when I graph it and I have a 0, okay, if you end up with a 0, that means you're going to have one real solution. And actually that's also going to mean that your x-intercept is the same as your vertex, okay? Because underneath here you get 0, so you're going to do negative b over 2a, you're not going to have anything else underneath there. All right, and then what I would like you to do in this portion is actually find your solutions. And you have a lot of different ways that you can do this. So in this case, we have x squared plus 10x plus 25 equals 0. I know that I can factor this. This factors into x plus 5 times x plus 5. When I solve that, I end up getting x equals -5 twice, but that's still only one solution. So the solution is x equals -5, which means it has one x-intercept and it has one real solution. So what I would like you to do is I would like you to take a minute and I want you to try these next two questions. I want you to hit pause. I'll have the answers up in a second, but I want you to decide between 4 answer choices. So we already did one with the one real rational solution. That's when the discriminant was 0. So you're going to decide, do I have 2 real rational solutions, 2 real irrational solutions, or 2 imaginary solutions? So go ahead, take a second and try it. Okay, so let's just take a minute and see how you did. You should have tried this on your own, and if you didn't get the same answer, feel free to reach out. Okay, so the discriminant here for this one should have been 361. That's greater than 0. So that's going to tell us, now when I graph this, if you notice, okay, there's 2 x-intercepts. So I know that I'm going to get 2 real solutions, okay? Now, I just have to decide if they're rational or irrational. Now, I'm going to solve this using the quadratic formula. So what I did is I didn't have to do any work here because I already had that portion right here. This 361 is already right here. Square root of 361 is 19, so I can actually simplify this entire thing. -1 plus or minus 19 all over 12 gives you those 2 answers, okay? So this one has 2 real rational solutions and 2 x-intercepts. And the reason it was rational was because this is a perfect square of 19. Underneath the radical, I can get a perfect square. If this is not a perfect square, it's going to be irrational. If you notice for this one right here, your discriminant should have been -16. That's less than 0, which means I have 2 imaginary solutions and no x-intercepts. If you were to graph this, you'll notice your graph is up here. It does not cross the x-axis at all. The solutions, okay, so there are solutions, there's just no x-intercepts, because if, crazy or not, if I plug this back into this equation, I will get 0 back out. And we'll explain imaginary numbers in a second. Okay, so these are your two solutions. So hopefully that will help you as we go through our discriminant. So the discriminant from the quadratic equation decides the number of solutions, roots, x-intercepts, and zeros the equation has. Okay, so remember the discriminant is just this portion right here. This is just going to be your b squared minus 4ac. Okay, that's going to discriminate and tell us what kind of solutions we have. Okay, so if b squared minus 4ac is greater than 0, okay, that's going to tell us that the discriminant is positive, okay, and it's going to say, okay, this is going to tell us that the discriminant is positive. Okay, the number of real zero solutions, roots, or x-intercepts is going to be 2. So they're either going to be 2 rational solutions or they're going to be 2 irrational solutions. So rational is going to be, remember, it's a perfect square, so like the square root of 4. Irrational is going to be not a perfect square, such as the square root of 5. Okay, so it's going to be where it crosses the x-axis. Okay, so it's going to have 2 solutions, 2 x-intercepts, 2 zeros to make your equation true. Now, if it's equal to 0, if your discriminant is equal to 0, what that is going to mean, remember, that's going to be where your graph touches the x-axis once, and that's going to be the same place as the vertex. So the number of real solutions is only going to be 1. Okay, and it's always going to be 1 rational solution because there's nothing underneath the radical as part of our quadratic formula to find the irrational solution. Okay, all right, b squared minus 4ac, that means my discriminant is negative. Okay, and the number of real solutions, zeros, roots, x-intercepts, is none. The number of an imaginary zeros, roots, x-intercepts is 2. Okay, you always have to have 2. Okay, you can never have one imaginary solution, and I'll explain why in the next portion. You have to have 2. Okay, so what that means is your graph is going to be in one of the 4 quadrants where it does not touch the x-axis. Okay, so there are no x-intercepts in this case. Okay, in this case right here, there will be 1 x-intercept. All right, if you have any questions, please let me know.